This video will all be about assigning E and Z. But what is E and Z? This is a nomenclature used to name double bonds. It tells us where the major groups are relative to each other and relative to the double bond. E describes groups that are on opposite sides, and Z describes groups that are on the same side. This will become clearer when we look at examples. The first example is the simplest alkene, which is but-2-ene. The first isomer looks like this. As you can see, the methyl groups are opposite each other, because we have one below and one above the double bond. Knowing about E and Z, we can assign this as the E isomer. Now looking at the other isomer, it looks like this, and we can see that the methyl groups are on the same side. And knowing about E and Z, we can assign this as the Z isomer. Now let's move on to a more complicated alkene. So if we look at this, which looks a little bit like this, with our chlorine atom and our ethyl group and methyl group and the hydrogen there, now we can assign this as E and Z. But how would we do that? First, we choose a side of the double bond. So we're going to choose the left-hand side first. And second, we choose the highest priority substituent. This may sound complicated, but it's actually really easy. The simplest way of doing this is to label each substituent with its atomic number. So we do this by following the bonds after the double bond. So here is the left side, and when we follow the bond down, we get to a hydrogen, which has the atomic number of 1. And when we follow the bond up, we reach a carbon attached to a methyl, and this carbon here has the atomic number of 6. So the carbon will be the highest atomic number, and therefore it is the highest priority substituent. So we can give this a circle because this is the one we need. We can then repeat this step for the right hand side, which looks like this. So following the bond up, we reach a carbon, which has the atomic number of 6, and following the bond down, we reach a chlorine with the atomic number of 17. The chlorine has the highest atomic number and is therefore the highest priority substituent. So we can circle this. Now the last step, is it E or is it Z? Well, looking again at our molecule, we can now circle, as before, what we say are the highest substituents. So are they on the same side or on the opposite side? They are actually opposite. This makes this the E isomer. Now let's look at an even harder example of an alkene that involves a carbonyl here. So following the success criteria, we'll choose a side, and again we'll go with the left hand side, and now we label the highest priority substituent. Now as we draw this, you can see that following the bonds, we get to a carbon here and a carbon there. So these are the same. Then what we have to do is take a look at what is attached to each of these carbons. The easiest way to do this is to draw a tree diagram. So redrawing this, we get carbon here, and following that along, it goes to another carbon, as well as a hydrogen and another hydrogen. The carbon on the bottom following it along, goes to 3 hydrogens. As you can see, the top carbon is attached to another carbon as well as 2 hydrogens, whereas the bottom carbon is only attached to 3 hydrogens. This makes the top carbon our highest priority substituent. Now we repeat this step for the right hand side. So redrawing it, we get this. This time we have a carbonyl. Drawing another tree diagram will help us see which is the highest priority substituent. As we followed this along, we go to a carbon which is double bonded to an oxygen. On the tree diagram, we will draw this as 2 single bonds to oxygen, followed by the single bond to a hydrogen. The bottom carbon, as you can see, is bonded to 3 hydrogens. Looking at this, we can see that the top carbon attached to 2 oxygens will give us the highest priority substituent, as the other carbon is only attached to 3 hydrogens. The final step is to assign it as E or Z. We can circle what we said were our highest priority substituents, which is the carbon here and the carbon here. And we can see that these are on the same side, which makes this the Z isomer. To summarise, we can make a success criteria. Step 1 will be to choose a side. Step 2 is to choose the highest priority substituent. Step 3 is to then repeat step 2 for the opposite side. And lastly, step 4 is to look, is it the same side or opposite side? Which will then tell us whether it is Z or E. And a top tip to remember when doing it is that Z equals Z same side.